Hey everyone, my name is Anvita Bansal and we are back with another lecture based on backtracking. Let me just check if you guys are able to see my screen. Yes, I think we are live, right? I just want to ensure if what we're going to discuss today is, let me just show you, have a look. Sudoku solver is the one that we are going to discuss today, and this is your problem statement. So let me first tell you the question. I hope you are already aware of it, but let's have a look. So what you are given in this question is, many people get scared while they look at this problem, looking at this tag hard. But whenever I have discussed the problems that are based on backtracking, I always say these hard problems of backtracking are actually not hard. You can treat them as puzzles. Actually, these are just the puzzles. Once you understand the logic, once you are well versed with backtracking, the problems are very easy, trust me. So just they look lengthy, they are lengthy, but they are very easy. Okay, so let's see what is Sudoku. I'll just go on with the question now. Let me tell you what you have to do in this particular problem, that you have to return true or false. They have given you a pattern, right? They have given you a grid, which is a 9 cross 9 matrix. So as you know, in Sudoku you have certain values already present in certain places at the grid. So you have to tell if this is a valid Sudoku or not, right? So what is valid Sudoku? Let's understand. Okay, so there are three rules whenever you are trying to play the game of Sudoku. The three rules that whichever number, so this is a matrix like this, right? This is a 3 cross n cross n matrix, particularly 9 cross 9. We are solving Sudoku problem for a 9 cross 9 matrix. So what do you have is, each matrix is divided or can be treated as combination of how many total? 9, 1, you can see like this, not 9, this is, okay, let me just draw it. So this is one matrix, this is other matrix, this is other matrix, right? So these, each of them is like this. Let me just draw it quickly. It looks something like this. Each matrix, so this is 1 2 3, 1 2 and 3, fine. Further 1 2 3, further 1 2 3. Okay, so this is how your Sudoku matrix is going to look like. Okay, this is 1, can be treated as 1 2 3 1 matrix. This is the other one, 1 2 3, and that is the other one. So I'm sure you are understanding, and so on and so forth, like this. Okay, fine. So you are given some pre-filled values in your matrix. In this question, these are like this: 3 6 5 2 8 7. So 3 6, whereas, sorry, 3 6, next one is, let me see from here, 3 6 5, it's 5 2 8 7, so on and so forth. So what are the three rules of while playing Sudoku? And so I'm not creating complete matrix. So what you are given some pre-filled values. You have to fill the empty spaces with numbers from 1 to 9, such that, rule number 1, the number is not present in entire row first of all, and that entire row should not be containing that number. Okay, that means each column and each submatrix should have distinct values from 1 to 9. Let me rewrite the rules as follows. Each row each row each column and every submatrix which is of size 3 cross 3, okay, of 3 cross 3, all these three things should have distinct values starting from 1 to 9. It can be in any order, but they should have distinct values from 1 to 9. Okay, so I will show you some examples of valid Sudoku for those who are not aware of it. Valid Sudoku. Let me show you some images. So if I show you this one, or let's see this, okay. So what you can see here, just imagine that all the red ones are the ones that you wanted to fill. Okay, so how did you fill these red values? Let's say you started with 4. So when you started with 4, you made sure that that particular 4 is not present in the entire row, right? So if you see 4 is not present in entire row, similarly 4 should not be present in the entire column as well, except from one place, from this place, and it shouldn't be present apart from here in this submatrix also anywhere. In short, you can also reiterate this rule as every row, every column and every submatrix will have numbers from 1 to 9 without any repetition, because there are 9 places only overall. So see, 1 2 1 2 3 4 5 6 7 8 9, right? Let's have a look in this column. 1 2 3 4 5 6 7 8 9. Let's have a look in this particular matrix, which is a 3 cross 3 matrix. 1 2 3 4 5 6 7 8 9. Understood? So this same thing goes for each and every box, empty space that you would want to fill. Let's say you wanted to fill this value here, which is in red, 5. What if I tried out 4 at this place instead of 5? Would it be a valid Sudoku? Let's fill up 4. For example, this is 4, this place is 4. So check if you have 4 already in this column. So yes, 4 is present, so it will deny to put this value here. So from here we will understand 4 will not be a valid number to place here. Okay, so like this we are going to understand how we can solve this problem. So I hope the rules of playing Sudoku are clear. Very simple, it's like a puzzle. Okay, now how can we ensure that we are going to get a valid Sudoku for the given configuration in your question? Let's say this is your given configuration. If it can be formed as a valid Sudoku, it will return you true. Okay, that means the numbers are placed in such a way that if I try to fill up the empty spaces, I end up getting at least one solution which is of a valid Sudoku, right? There we will assume that there is one solution possible, and if it is possible, then we will return true. If that one solution is also not possible, that means the given grid is somehow not implying the rules of Sudoku, so we will return false. Okay, let's understand this question. What can we do? So for each empty space, whichever empty space you are given, let me see if I can copy. Whichever empty space you are given, let me just take this example. Okay, so this is the given matrix. Okay, fine. Okay, let's have a look. So each zero indicates that that value needs to be filled up. Okay, so I let me just write it as if it is a matrix only, and ignore the commas and any extra space that you have. So you got a matrix here. Okay, let me just fill up zeros as empty. Zeros are let zeros be white in color. Okay, fine. So this is your 0. I think that's okay. Okay. So let's start. How can we start? First of all, we will iterate over a matrix. How do we iterate over a 2D matrix? We take a loop, right? That starts from 0th index, goes till last index, which will be what, 8, right? So let me make it less than 9, I plus plus. Okay, next thing, what, iterating over the columns, j equal to starting from 0. We know that matrix is going to be of size 9 cross 9, so I am directly writing this. Now what you have to check, first of all, while you are iterating, you will check, do you have an empty space? Each empty space in the matrix is represented by 0. We know that we can only fill up the values from 1 to 9. So whenever you find a 0, that means you should try out what are the possibilities of filling this position. So I will first check if my this particular matrix of what, ij, right, is it equal to 0? If it is equal to 0, that means I need to do some work. What is that work? I will start placing some values in it, and what all possible values I can put in that position from 1 to 9. So why not start one by one? Let's say I start with filling up that place with 1. So for int, k equal to 1, k less than equal to 9, and k plus plus, right? What I want to do, I am saying that I want to place this value here. Let's say I fill it up with 9, fill it up with 1. Okay, if I fill it up with 1, then am I going to get a valid Sudoku? So that's what I want to try. How will I find that answer to myself? So that answer can be found like this. If I put 1 there, so what is my Sudoku going to look like? 3, 1, 6, and everything as it was. Let me do one thing, do this change here only. Okay, fine. So if I place 1 there, how is your matrix going to look like? I will have to place by looking at some conditions that it satisfies, and those conditions are, let's say I put a 1 here. Okay, and let it be in this yellow color. Fine. Okay, so how is your matrix going to look like? If I put 1, I have to check, does that subsequent row, this entire row should not be having 1 in this case. Does it have 1 as of now? No. I have to check in this entire row if it has 1. It does not have 1. You will check one by one. It has 1? No, it doesn't have. Then you have to check in this entire submatrix of size 3 cross 3. So 1 is part of which submatrix? This submatrix is what 1 is part of. If you see, this is the submatrix whose part this 1 is. So I have to check, do I have 1 already here in this matrix? No. So I can say it is safe to place 1. So try when I put 1 here. Okay, when I put 1 here, now let's see which is the other empty position in my matrix which I can fill. So okay, I said one possibility was 1. I place it there. Now what? Now try out the other empty space. You go and check row wise. Okay, you check row wise. For each row you are checking out each column. When I placed 1 here, I could say I can safely place. Now what is the next thing that you can fill up? So I found a 0 here. Again the same possibilities, your matrix ij is 0. Now you start filling up from, so I have 1 to 9 possibilities, right? You start off placing 1 here also. So if I place it 1, I will first check, does my row contain 1 already? Yes. So this row will tell me that 1 is already there, so you cannot place 1. So I will try out another possibility, which is 2, right? So when I place 2 here, I will check, does it contain 2? No. Does this column contain 2? No. So which submatrix is this particular place, or this particular position is part of. So this position is part of this 3 cross 3 submatrix. So does this matrix contain 2? No. So I can say it is safe to place 2 here also. So in terms of recursion, if I talk about, I hope you're getting the gist of what I'm trying to do here. If I take a look at how recursion must be looking like, so what is happening typically, that you are making a call for each position whichever is filled with 0. You're making a call for it. So I started with this 0 comma 0, means everything was which is 0 initially is still 0, let's assume. Then what I did for this position, which was I equal to this is 0, this is 1 2 3, let me just erase this. Okay, so let me write the indexes: 0 1 2 3 4 5 6 7 8. Same goes 0 1 2 3 4 5 6 7 8. Okay, I started with the first position that I wanted to fill, that was at index 0 comma 1. So for 0 comma 1 I filled this one with 1, and the matrix that I got was whatever was the grade. Now in that grid I again applied recursion, and on further recursion I found out that the next position that I wanted to fill was at which index 0 comma 4, correct? So 0 comma 4, for 0 comma 4 I placed which value, I tried out with 1, but I returned false from there, that you cannot place 1 because 1 was already placed into this matrix. Okay, then I go back from here I try out another possibility, that is placing 2 at this index. Which index? 0 comma 4. I am placing 2 at this position. So is it safe to place? So yes, I, as of now, my whichever function is handling this thing, it will say yes, you can place it. So now in my matrix the situation is that this position is also filled with 2. So what is the next index that I want to fill? If I go according to this loop, the next position will be at 0 comma 7. So let me make a recursion call. So I made a recursion call from here, that is for 0 comma 7 index, and for which number I tried out, I will try for 1 first of all, it will return me false. Then I will try for 2, it will also return me false, because in the same row 1 has been put, 2 has been put as of now, and you are trying for 1 2, so it will return you false. Now the next thing that next number I can place it is 3, but when I try to place 3, my recursion call will go and check if I can place a 3. Not recursion call, is valid, let's say, is a function which is checking if I can place a number. Okay, so basically what is happening, when I am entering in this loop, for each number I am trying to place in that position until I am not able to put a valid number. So I will ask my function is valid. If is valid, before if let's say I have a function if is valid of this grid and whatever arguments I am passing, if this returns me true, then what I am going to do, first of all I will fill that position, empty position in my matrix, what is it, at index I comma j, matrix of I comma j will be placed with this character, which number, k. Okay, this will be placed with k. And the next thing that I'm going to do is, since I found out that this position is valid, now try to see by placing this number here, what is the valid Sudoku, that can I get a valid Sudoku. So I will make a recursion call for the same function. Let us say that this is the function solve. Okay, you are doing calling a solve function, which is just taking the argument of this matrix, and you are iterating over that, checking for each value, whichever is the empty space, you fill up that position, you ask your valid function, can I place that value, it will return you true. If it returns you true, you place that value in that position, and then you make a call, and then what you do, you make a call back to your function solve, right? Solve. Why? You will ask it, if this returns you true, right, then you return true. Otherwise, in the else condition, what you are going to do, the value that you placed in that position, you remove it from that position back. You make it 0 back again. Why I did so, I'll tell you. Okay, so let's understand what I'm trying to do. So I placed 1 here, then 2, then 3, then 3 will be denied because 3 is already present. Can I fill 4? 4 will be denied because 4 is already present here. 4 will also be denied. Okay, what can I do? Let me try for next fifth, that is value 5. 6, 7, 8. I am trying for 5. Can I place 5 here? 5. 5 is also not valid because 1 5 is already in this row. Can I place 6? So in row I will check, yes I can place. For column I'll check, it will say yes you can place. Then which submatrix is it part of? This 6 is not present, so I can replace this 0 with 6. Okay, so my is valid will say true for 6, right? So that means I can place 6 here. So when my is true is valid will return me true, matrix of this ij will be filled with 6 according to this line. Okay, then next thing what I'm going to do, I'm going to make a recursion call from this index, right? Means I am at this index and I'm making recursion call and checking, keeping these values intact, what are the other possibilities. So from here 3 will be a valid number. So I make another recursion call with what all values which we have already placed, in which we have taken 1, 2 and now 6. I think 6 was the number, right? Yeah, so with 6 as my valid number, I made another recursion call for is Sudoku, and it goes and uses these two loop and it will check that again which index is 0 in this particular row. So I will find this. Now I will try to fill up values from k equal to 1 to 9 for index 0 comma 8, right? So at 0 comma 8 I will try 1 2 3 4 5, it will be denied. 6 will be denied. Let's try for 7. If I try to place 7 here, let me check if my column contains. No, column doesn't contain. Does my matrix contain? No, matrix also does not contain. So I can safely place a 7 here. So if I place a 7 here, you will see that this will return me true, is valid will return me true. So I'll place a 7 using this statement and then apply recursion from here again. So what was this? At index 0 comma 8, I filled the value 7, right? And then I applied recursion on this state of my matrix, and my loop will again go ahead and check for the next empty index, which is this index, and it will do the same thing. So what is the gist here? I hope you understood the flow of this problem. Each time it goes and checks the validity. So if I cut this short down, for each row, basically for each empty space in matrix, let me write down like this. For each empty space which is 0 apparently here, for each 0 in matrix, okay, what you are trying to do, for each 0 in matrix you check for k equal to 1 to 9. You check out which is the valid number you can put. So you ask your one function, let's say I have written is valid. You ask if is valid function, you ask your valid function if by placing this value in my matrix, so you will pass this number k, is valid task will be to check if I can place k in matrix or not, if that's a valid. So how will it check? It will check on the three basis. The basis of its check will be if k is not already present in the same row, if that k is not already present in the same column, and if that k is not part of that submatrix, sub 3 cross 3 submatrix, right? So based on these three criteria, your is valid is going to return you either true, or if one of them fails, it will return you false. So if this condition is true, you are going to do one thing, which is if that is true, you will place that number whichever you chose from here into your matrix. Okay, so matrix of I comma j will be filled with k. Okay, if let's say this returned you false, then what are you going to do? Then you are going to, I think, let me, okay, okay, so if it returns you false, you are directly going to return false from here. The reason is, one second, I think if this is true, you will fill up with this in the else condition. Sorry, one thing I missed here, which was, if this is true, then you are going to apply recursion. That's what we are doing, right? So if this is true, the next thing that you are going to do is, you will, let's say this is your function, you will make the function call for the current state of your matrix, whatever the state. What is the current state? That you picked up some k which turned out to be a valid number for this index. Then you will make a function call, which is where you are applying recursion. Okay, this is where you are applying recursion, and then your function will go ahead and check that with all the valid k's that I tried to put, what are the other possibilities at the empty position to fill up the values. Okay, then the same thing will go on and go so on and so forth. Okay, let's come out of this. If, let's say, if is valid returns you false. Okay, so what are you going to do? So if this is valid was true, then what you did was you filled this with that particular number. If this is not true, then first of all, you are trying to backtrack, right? So you will backtrack if this function is also of type boolean. That in code, when I will take the code, you will understand what is happening. Whenever there is a valid, you ask your valid function, it returns you true, you fill up that position with that k. Okay, and then immediately you go and make a recursion call to the same function in which you are currently, which is your, let's say, func. You ask if that function returns you true. If it returns you true, you will return true. Otherwise what you do, this is else for this particular if, and it is still inside this if condition is valid. So in the else case, since you have already filled this matrix with k, you are now backtracking. So here you are making a recursion call, now you are backtracking. And since it turns out, if when I tried to fill that empty space with k, I made a recursion call to my same function, and it checked out all the possibilities and finally returned me false, let's say, means it did not return me true. So what will happen? That means the k that I tried to insert into that empty position did not return me a valid Sudoku. So what I must do now, the position that I filled with k, I should make it back to its original form, that was when it was 0. Okay, now whatever was your k, let's say your k was 3, now you will try out the possibility for another k. That's what you are going to do, and do the same thing and repeat the process. So this is your backtracking step. Okay, and when you come out of, so this is your else for this if your function, if your recursion call doesn't return you true, then you are going to find out other possibilities for this game. When, let's say, you explored all the options from 1 to 9 and you still did not get a true from this if condition, that means you never found a valid Sudoku for that position by filling it up with 1 to 9. None of these possibilities returned you true. That clearly means when you come out of this for loop, you can safely return false, which that indicates that there was no possibility to get a valid Sudoku. You tried out all the case from 1 to 9 for that I comma j, but none of them return you true, which means there's no way that I can get a valid Sudoku. And let's say none of these conditions hit, in the finally you'll return true for the sake of returning to this function. So this is typically about this function. Let me just go walk you through this function that I was talking about. So this is your function that is given to you in this question to fill up. Okay, let me just do it like this. Fine. So what are we going to do? As I told you, you start as per our pseudocode. You can have a look here. For each empty space in the matrix, first you want to find the empty space. So for that you need to iterate over your matrix, right? I less than what? 9. Okay, and I plus plus. Then I'll quickly write it for int. I'm writing code. It could have been much not easier, but it would have been much less time taking if I had just make you go through the written code, but I am writing it so that you understand it each step, whatever I explained, that how it is mapping to what we are actually coding, right? So I just want you to understand each step. That is why I'm writing this, because see, this I always take these hard questions, especially of backtracking, as simple puzzles, which are genuinely very simple if you understand the logic. Okay, so for int j equal to 0, j equal to 0, j is less than 9, j plus plus. Now what are we checking? Let me just put this and check if you guys are able to see my screen. I think my video is lagging a lot. Let me just check. What is the upload speed? Very bad. Let me just change my internet. Let's see. Okay, coming back to the code, what are we doing here? So for int, yeah, I am first checking which position is 0. If your grid of I comma, let me just take up the code quickly. So I am checking if your grid is 0 for the day. If is valid, let's say is valid is returning you true if you can place that position. But before that, you have to, now you will place values from 1 to 9 one by one. So for int k equal to 1, k is less than equal to 9 and k plus plus, correct? What you will do, you will ask if is valid function. For what you are passing, you are passing grade, you are passing the row which is I, you are passing the column which is j, and you are passing the number which is k. If this is true, then what? First of all, you will check, 1 second, k is less than or equal to 9. Then if this is valid, returns you true, then you will first of all place that k in that particular index I comma j will be filled with k. Now what? Now you will apply the recursion call that with this state of your grid, are you able to find a valid Sudoku? So you will make a recursive call back to this. So if solve Sudoku returns you true, right? If it returns you true, then return true. Okay, return true. Otherwise what? In else case, since you already filled that position with some k and you did not happen to get a valid Sudoku by placing k at that position, so you bring it back to its original position, else grid of ij will be 0 back again, right? Because this is what we did before getting into recursion. But since we did not get a valid Sudoku from there, I am backtracking now. I'm backtracking over and over again until I get a valid one and return true. So I have to bring my matrix back to the original position at which it was there. Fine. This is why I'm doing this step. And now what else? When you come hit this, the end of this for loop, this was for if, this is for, you can say that if you do not hit a true from this for condition, you return false. That means there was no valid Sudoku found. You tried out all the possibilities for that particular index, and for the sake of this function call, because this is of type Boolean, you should be returning true. Okay, although your answer will be handled from here and here anyway, but okay, that's what we are doing. Fine. So I think this is okay. Now coming on to is valid function, let me write a is valid function. So for public static void is valid. Okay, so is valid is taking your grid, it is taking the row, int r, int c, and int num, what number you are placing at that position. So I already told you, you are going to check for that entire row, entire column, and in that entire 3x3 matrix. So I is less than 9 and I plus plus. Let's say I am taking one index. So first I am checking if that row contains this num or not. If it contains, you return false. So if my matrix, my grid of what row, that means r will be fixed and my column will be changed, that will be from 0 to 8, correct? Fine. If it is at any point I get num, I return false. Same for the other one. If grid of I comma c is fixed, you are checking in the same column that any row index for that particular column has num, you return false. The next thing is, how will you find that in that submatrix you have that number or not? So how to mathematically understand or iterate over it. So let's say I am at any index. Let's say this is the index I am trying to look for. What is this index? This is 4 comma 1. So for 4 comma 1, if you want to know what submatrix it is part of, I can try to know what is the starting index of its row and starting index of its column. That if I can know that, then I can safely iterate over that submatrix and try to know. So how can I do that? See, for 4 comma 1, what is your row? You can do it simply like this: 3 multiplied by that index I divided by 3, okay? And this is your rows index, and your columns index will be the same, 3 multiplied by that j divided by 3. So if you use this, what are you going to get? 3 into 3 multiplied by 4 by 3. 4 by 3 is 1, right? And 1 into 3 is 3. So your row is going to be index 3 and your column will be 3 into j is what? 1 divided by 3. It will be 0. So this is your 0. Fine. So this tells you the starting row index and the starting column index for that matrix for which this is part of. So 4 comma 1 is a part of a sub matrix whose row and columns, basically whose starting position of that submatrix is at 3 comma 0. So if I know this, that this is the starting of this submatrix, right? So you were trying to check for 4 comma 1 and you got somehow 3 comma 0, which tells you that the starting position for this submatrix is at 3 comma 0. So you can just iterate from here or for all the indexes, for all the positions, and check. If you are finding the same number, you return false. Let's try and apply this formula for some other index. Let's say I have this number. So if I want to know that what submatrix it is part of, I just want to know that what is the starting position of that matrix for which it is part of. So ideally this is part of this submatrix. If I draw a boundary, so this is the submatrix for which your index 5 comma 6 is part of. So 5 comma 6 is part of this submatrix. So I want to just find the index which is 3 comma 6. So I just want to know 3 comma 6 so that I will know that submatrix starts at 3 comma 6, right? This 3 cross 3 submatrix starts at 3 comma 6. So I'll use the same formula, that is 3 multiplied by 5 by 3, and for column 3 multiplied by this 6 by 3. So what are you going to get? So this is 1, this is 3, so this is 2, and this is 6. So you got 3 comma 6 finally, right? And if you ask me why am I doing so I'm sure that you must have done this before also, since this is 3 cross 3 submatrix. So if you try to do it on your own, this is nothing why we are doing so. I think this is simple mathematics. It doesn't need any explanation. Since this is a 3 cross 3 submatrix, any index for a row, if you're trying to find, if you divide it by 3, right? So you whatever you have means, I don't know, I'm explaining this, and I'm sure that if you try to do manipulations on your own, this is not the only thing. We have used this thing in a lot of other questions also in a matrix. So if you are finding some other mathematical formula that comes to your mind, you can do that manipulation. Anyhow, this is some, you can say, hit and trial method to find the formula which can help me know what is the starting index for that 3 cross 3 submatrix for at which that position is part of. Okay, so that's pretty simple. So I am going to use the same thing. I want to find the row and column. So int r, or you can say this int row is equal to, let me just take it from here, int row will be, I'm just quickly doing it now. So what I did, I asked int row is equal to 3 into whatever row index was given to you, that divided by 3, same for column, right? So I got the starting index of that submatrix, so now I treat it as another 3 cross 3 submatrix whose I and j, let's say when it starts from 0 you do the same thing, right? So now in this case it's starting from rowth index and I have to go till row plus 3 just with the spaces. Let's check. Grid IJ. Okay. What is the issue? Let me check. 50 incompatible. Why? Static boolean. Let's submit it. Done. So you guys can tell me if you have any doubts in this question. You can ask me. Let me just check in the comments if you have any doubts. Good evening, Prerit. So that is about this problem. So I'll just one more time for the last time, let's have a look what we were trying to do since the video was lagging a bit. So what we are doing in this question, we have taken a matrix which you can see here, right? So this is your matrix, and in this matrix I am trying to, for each position in the matrix I am going to check which indexes are 0 in the matrix, right? Which are the zeros. So I will start filling up those zeros. So when I start filling up this 0 with 1, I will ask my is valid function. If that returns me true, I am going to fill up that matrix with that position which is 1. Okay, so I'm also simultaneously writing which index I chose. So I chose 0 comma 1 and tried 1 at that position. So what matrix I'm going to get? So I'm going to get a matrix like this: 3 1 6 6 5 0 8 4 and so on and so forth, which I'm not writing. Okay, then another recursion call is made for the next 0 0 in your matrix. So what is the next 0 in your matrix? The next 0 is at which position? Next 0 is at 0 comma 0 comma, this is what, 4. Okay, so at 0 comma 4 I will first ask if I can place 1. So 1 will return you false. From where will I get this false? So see, when I place 1 here, my is valid function will be false. Okay, if it will be false, I will go back to this for loop and do the next iteration. So for k equal to 2. So for k equal to 2, if I try to place it, maybe I can place 2 because row and column does not deny. So, and this particular, in this function is checking if that row is denying, it will return false. If that column denies, it will return false. If that submatrix denies, it will return false. So none of them will return false if I replace this value with 2. So I replaced it with 2 and made another recursion call. So when I placed it with 2, my matrix was something like this: 3 1 6 5 2 8 4 and whatever are the other values. Now when I'm making another recursion call via this function, it goes again back to the first line of this code, which is for each row and column check which is the next position at which you are finding a 0. So the next position at which I'm finding a 0 is this position. Do the same thing again, everything. So what will happen is, by the end, let's say I tried 1, then 2, then next possible value that I placed here was 6. Okay, and no, not 6, I think it was 7. It was 7, right? So then it will also, if I can place 7, no, I cannot place 7 because column has it. What if I place 8? 8 is already here. What if I place 9? Can I place a 9 here? Yes, I can place a 9. So let's say at this index I am placing 9. And then this is the next index that I have to fill. So what can I fill it with? With one is there, 2, 3, 4 is there, 5, 6, 7 is not there, and yeah, 7 is not there. So I can fill it up with 7, right? So this is what my recursion is going to do. 7 is not here, 7 is not in this submatrix also, and not in the same row. The next position that I would want to fill is this. So what will happen, whatever, these are my hit and trials, right? Recursion is trying to create answers, but let's say at some point in time it clashes with the value what I placed here. Let me take which value I can take. So if I take 1, 1 is already there in the matrix, 2 not, 3 is here, 4, I think I can take 4 here. So if I use a 4 for this position, what is the next answer I can get? So this is the next position that I would want to fill. So 5 is already here. What if I take 6? Can I take a 6? No, 6 is already in this sub matrix. Okay, 7. If I take 7, so I think you got the gist. What is this recursion doing? For example, let's say I place a 4 and it denies if valid is false. So what you are going to do, you will first, since you placed a 4 here, you will remove that 4 and do a backtracking and explore other options with this state of your matrix. So that's the entire problem. Okay. Okay, you want to understand is valid. So what is happening in is valid? Since I told you, we are trying out all the possibilities for that empty position. I am starting with 1. How do you fill a Sudoku? So this function is telling me, can I place a 1 by checking out 3 conditions. So these 3 conditions are, you will check if that entire row has that number at any point in, if at any position, let's say this is exactly what I was explaining. So if I try to fill up this number, I'm starting with 1, right? So let's say I take 1 here. So is valid will do what? One second. Is valid will take num as 1, then it will check in, I have taken this indexing from 0 to 9 exclusive. Then in the grid I will check if that entire row has 1 already present in it. So this is what it is doing. So this is checking for column, if that column has number 1. So I will check 1 if this column, yes, this column contains 1, so I will be returned false. So this false will be returned to this function from where I called it, and hence it returned me false. I cannot go ahead with 1, so I will try out the next possibility, which is 2. So I try to place a 2 here, and then I try to check my function is valid will check in this entire column 2 is there or not. No, 2 is not there. Then it will check for the entire row. If grid r is fixed, which is this row, and I is via iteration, so for each iteration of column in that fixed row, that is in this entire row, it will check if 2 is there. 2 is there? No, 2 is not there. So you can safely place a 2 here. Before that and after that, it will also check for the other third condition, which is if that sub matrix, so this 0 is part of which submatrix? This submatrix. So if this contains 2, so it will return false. But as of now, this submatrix also does not contain 2. And how am I finding that what submatrix it is? I am trying to check what is the starting index of this submatrix using this formula. So this is simply mathematical manipulation, nothing else. And if it returns you false, you will return false, and none of the conditions return you false. That means you can safely place that number, and then you return true, that after which you place that number in the grid and call out recursion is calling out this function back again and trying out all the other possibilities with that state of your matrix. So I hope now the problem is clear to you all. So since this is an SD sheet, we are following the SD sheet from here, and we have already taken up so many questions. So the people who are trying to follow up with every question that we are discussing, it they need not necessarily always join at this time. They may come back once they have tried this question on their own. So the intent is that one by one we are able to, I'll just show you this. So what is the intent? If you see that we can, Let me show you. Wait, if I go to this practice, we have this SD sheet, right? So in SD sheet, we have taken up all the questions right from whatever topics are there, and this is your sheet. So we have arrays. So what all topics are there in SD sheet, we are covering it one by one. So the people who are trying to crack some interview, they must at least solve each of these problems, and every day I'm taking one. So you try to do it on your own. If you don't get it, you come back and watch the video. So that's the, and that's the best approach that you can follow. So right now we are at this topic, recursion and backtracking and solve the Sudoku, right? So if you have any doubts, you guys can ask me. Let's go back to our session. Fine. So good to know, Prerit, that you are learning, coming here and learning. Keep coding. And if you have any doubts, you guys can ask me. Try to understand the logic behind the problem, and then code is very simple. Okay. So if you have no doubts, I'll just wrap it up, and that's all. This is your code. Fine then. Thank you everyone. Bye bye. Take care.